In this video, we'll introduce calculus, which is the largest topic on the IB/SL syllabus. So what is calculus? Well, in the simplest terms, calculus is a branch of mathematics that deals with rates of change. For example, maybe you want to calculate the change in velocity of a car rolling to a stop at a red light. Calculus can help you figure out that change. That's right, calculus puts movement into maths. More specifically, what is calculus used for? Well, calculus is used to model many different processes in real-life applications requiring non-static quantities. Throughout your maths journey, you use calculus to find a derivative, evaluate the limit of a function, explore variables that are constantly changing, employ integration in solving geometric problems, solve differential equations, and that's just the beginning. Throughout the course of calculus, you'll use very specific terminology. Here are just a few. Derivative, the instantaneous rate of change of a function with respect to a change of a variable. Differentiation, the process of finding the derivative. Function, an expression that illustrates the relationship between an independent variable and a dependent variable. Integral, an expression that illustrates the relationship between an independent variable and a dependent variable. Integration, the process of finding the integral, which is the inverse process of finding the derivative. Basically, calculus is advanced algebra and advanced geometry. In the picture on the left-hand side, you've got a man pushing a crate up a hill with a regular gradient. He uses the same energy no matter where he is on the hill. Whereas in the picture on the right-hand side, the energy required to push the crate up the hill is constantly changing because the hill does not have a constant gradient. That changes a regular maths problem into a calculus problem. In both these pictures, we're finding the length of a cable. In the left-hand picture, we're finding the length of a cable that has been stretched between 2 points. So it is straight. We can do this easily using Pythagoras. Whereas in the right-hand picture, the cable is between 2 supporting pylons. It is not straight, and this changes a regular maths problem into a calculus problem. In both these pictures, what we want to do is find the area of the roof. In the house on the left, the roof is made up of geometrical shapes, rectangles and triangles, which we can easily find the area of. Whereas the dome is not a regular shape that we can find the area of. It is a three-dimensional circle, a sphere. This changes a regular maths problem into a calculus problem. Differentiation, rate of change. In this example, we can see a graph that shows the total cost of renting a boat by the hour. The total cost of the boat is constantly changing as time changes. So this is a rate of change of cost with respect to time. So we can write this as dc over dt, the rate of change of cost with respect to time. If we look closely at the graph, we can find the gradient of the graph. So it goes from 8 to 11, so that's a change of 3, over a time going from 1 to 2. So the rate of change of cost with respect to time is 3 over 1, which is equal to 3. So the cost of renting a boat changes by $3 every hour. Using the equation y equals mx plus c, we can find an equation for the cost of renting the boat, and it is c equals 3t plus c. Now if we take the differential of this, dc over dt, that is equal to 3. We will go into this in more detail later on in the course, but that shows us that the rate of change, in other words, how much more expensive is it getting? It is getting more expensive by $3 every hour. Now, if you take the graph of y equals x squared, you can see that on the left-hand side, the rate of change is negative. That's because the gradient is negative. When we get to 0, the rate of change changes to being positive all the way round that graph. No matter where you are, the gradient or the rate of change is constantly changing. The rate of change for the graph y equals x squared is given by y dash is equal to 2x. That means that if we want the rate of change for y dash at 1, we substitute 1 into the rate of it, or the differential equation, which is equal to 2 times 1 equals 2. So at x equals 1, the rate of change is 2. If we want it, the rate of change when x is minus 2, we substitute minus 2 in, and we get 2 times minus 2, which is negative 4. So the rate of change of the graph y equals x squared at the point x equals minus 2 is minus 4.